Stanford University.
Welcome to the seminar on People, Computers, and Design. I'm Terry Winograd. Next week, we have Adrian Freed from Berkeley in the Center for New Music and Technology, I think it's called, which corresponds sort of to Karma here, but does a lot of interesting things. He's the head of the group on guitar and chordophone or something like that, and working on electronic textiles. So he has a really broad and interesting background in musical instruments as well as the technology. So it should be a fascinating talk. Those of you who know him saw he was actually here in the back of the room at last week's talk. So that's next week, Adrian Freed from Berkeley. This week we have Vik Singh, who is listed in various ways in the postings I sent out, with Yahoo being a sort of prominent entry. He actually has left Yahoo now. He was there most recently. He's now with Sutter Hill Ventures. But a lot of the stuff he'll be talking about is work that he did there. He has, in his relatively short career, given his age, been involved with research at Microsoft, Google, Yahoo, Intel. Am I missing some? Anyway, he knows what's going on in a lot of industry and has really done some innovative work around search in general in various ways. And today he'll be talking in particular about how that connects to Twitter, real-time social search.
Great. Thank you. Is this good?
Yeah,
okay.
That's fine. It's mostly for the recording, so
okay.
It doesn't have to file.
So thank you for the kind introduction, for having me here. I just wanted to talk about Twitter and what we did at Yahoo specifically, and why we actually were looking at Twitter, and maybe provide some thoughts as to why other companies are also looking at Twitter recently, and what we did and what approach we took in building applications with Twitter. Just a show of hands, how many people have used Twitter or know how it works? Okay, so I think I'm going to skip this slide. And for those who may not know too much about Twitter, I think this, this image really encapsulates what Twitter is all about. So when the U.S. Airways aircraft crashed into the Hudson last year, one of the ferries that was en route to, rescue the passengers had a ferry rider who was, who had Twitter on his mobile phone, and he tweeted an image of the event and described how they were going to go save them. And I think this was one of the first eyewitness reports of the event. And I think that's quite interesting because it didn't come from, CNN or Fox News or some traditional news outlet. It came from a ferry rider who was just trying to make his commute. I think, that's kind of what Twitter has enabled. It has enabled any of us to kind of become an eyewitness reporter and to be able to kind of spread, updates and information and news to our social network very efficiently and very quickly, and also very simply. And other companies are starting to realize this and starting to pick up on kind of the value of Twitter. Google just recently signed a $15 million deal to get access to their data. I actually went through the trending queries of the day on Google, and I found that on 20% of the queries, Twitter results were actually appearing. So this stuff is actually becoming very mainstream and still very early. If you look at some of the recent redesigns on Facebook, they seem very Twitter-like or Twitter-inspired. They're prominently showing status updates. They are, showing more real-time information, and it's, it would be hard to say that it wasn't inspired by Twitter and its success. Dell reported that they made $3 million in revenue using Twitter. They were using Twitter to communicate with customers and to also tweet out coupons. And I think this has actually been one of the most successful examples of social media marketing, which is just a fairly new industry, and I think in large part due to the services like Twitter. And maybe a reason for us to care about Twitter, Twitter recently announced that they're going to open up Firehose to developers. Firehose is basically near real-time access to all the tweets happening in their public system. And so this is actually, I believe, similar to the data that they're giving to Google, which Google is paying $15 million for. So if you're ever thinking about doing something with social information, social networking information, real-time information, mobile kind of stuff, you're going to have your chance and to be able to do it at scale. So I just kind of want to describe, how we looked at this problem while at Yahoo. I mean, it's a little bit different than maybe from other companies. Yahoo and specifically the group that I was in was the search group. We're looking at it from a search perspective, and we were really focused on, can we use Twitter to improve freshness of search, right? So a lot of results that you get back aren't necessarily from seconds ago. They may be days old or years old. And so there's this recent push to really try to improve the real-timeness and the timeliness of results in search engines. And so we thought maybe we could extract signals from Twitter, which has become known for being able to surface real-time information. And but before we actually did that, we didn't want to make an assumption that even Twitter was good at that. Because everyone was telling us that. The media was telling us this is the best thing to use for finding real-time information. But instead of making that assumption, we should really let the data tell us what's really happening in Twitter. Because people didn't really, people are still trying to get their hands on what exactly is happening in that system. So we took a more data-driven approach to building our applications. So the stats I'm going to describe today come from a full day of tweets in July of 2009. And what's interesting is if you look at the stats, it actually looks like the traffic peaked in July 2009, and it's gone down and flatlined since then. That doesn't necessarily mean traffic to Twitter has gone down, because this doesn't track mobile client usage. But this graph has been corroborated by many different sources, and so this nevertheless should make for a very interesting data set to party on. So in the data, we found 10.2 million tweets total. And this is a full day. There's no skips. It's whatever Firehose was giving us. There's about 100 tweets per second on average. And at the peak, there was 700 tweets per second. The total number of users found was 2.9 million users. And what's interesting, and that includes both the number of senders and the number of users who are receiving messages, or users that have an ampersand in front of their username. What's interesting is the number of users that sent at least one message or received one message in that day was 600,000 people, which is a lot smaller than I expected. The types of tweets that we found in this sample, 4% were retweets. That's essentially when a user sends you something and you find it really interesting and you forward it on to your friends. 38% of tweets had ampersands in them. And what was really interesting is I found that 20% of tweets had URLs in them. And in particular, 39% of retweets had URLs in them. So anytime someone was sending me something and I was forwarding it off to my friends, there's a 40% chance I had a URL in it. So there's a lot of link sharing going on inside Twitter. I found 5,000 plus bots in the system. I define a bot as a user which sent more than 100 messages in a day. And that constitutes about 10% of the overall number of tweets in a day. And depending on how you do the filter, roughly 2 to 10% of tweets look like questions. So I looked at things like question marks and who, what, where, when, why, and those types of things. And depending on how you do the filter, it's roughly around that range. This is my pretty graph slide. If you look at the upper left graph, basically the x-axis is log2 buckets of number of messages sent in that day, and the y-axis is the also on log scale the number of users. And so you kind of notice like a very Zipf-ian-like distribution coming down, but once you get to around 2 to 10 messages sent in a day, which is like over 1,000 messages, you start to see a pretty big gap fall down, and actually increases around 2 to 13 messages, and then it goes back down again. And so if you kind of just look into, who's sending more than 1,000 messages a day? It's not human. So the bot behavior is definitely kind of doing something different than the Zipf-ian distributions that we're used to seeing in social networks. On the right side, it's the same exact graph, except it's not the number of messages I sent, it's the number of messages I received. And we notice it's a little bit better, and it has about a negative, negative 1.3 slope. But interestingly, if you do the same exact graph, and instead of counting the number of messages I received, you count the number of unique senders that are trying to communicate with me. Because, for example, let's say I'm a fan of Britney Spears, and I send her like 10 messages. This is very hypothetical. I send 10 messages. That's going to count 10 times in the upper graph. It counts once in the bottom graph because I'm uniquifying the senders essentially. Really interesting. It's nothing unexpected. We expect to see kind of power law-like behavior in social networks. You have very few number of users who are generating most of the content. You have very few number of users who are attracting most of the fame. But nevertheless, it's always interesting to find this stuff, even when you splice the data a little bit differently. Another thing that I was interested in looking into was, is there a similarity between ranking users based on how many messages they receive versus how many people follow them. And I kind of assumed that they would be pretty close because, for example, Britney Spears has like 2 million, 3 million followers. And I'm assuming a lot of those are fans, and fans are probably trying to communicate with her all the time. So maybe she receives a lot of messages too. So I took a sample of top users, and I ranked it based on how many messages they received, and I also ranked it based on their follower accounts. And if you compute the Kendall-Tal rank correlation coefficient, which is just basically a way to kind of measure the similarity between two rankings and determine if they're correlated, and it gives you a score between -1 and 1. So usually when you go down the -1 range, that means the rankings are pretty much reversed. If you're at the 0 area, on average, that means the rankings are probably independent. And the more closer you go to 1, they're probably more similar. And the score you get here is around 0.242. I was expecting a little bit higher. Again, this doesn't have significance bounds on them. So more trials should be done and more statistical tests, but still kind of interesting. Another thing, and this is actually pretty important, is to know how much duplication of content is there in Twitter. How much of it is just me taking someone else's message and just copying it over? How much of it is tweets talking about the same topic? And so this is a little bit tricky to kind of discern because you don't want to just do exact string matching because that doesn't capture things like Britney Spears fell down, Britney Spears falls downstairs. I mean, they're the same thing, but they're not exact. Or if people are retweeting it, the strings can change. So, I mean, the naive approach would be just to go through every message and then look at every other message and then compute some type of similarity, like a cosine metric or some type of information retrieval metric, like a Jaccard metric. But that's kind of expensive, right? Because even over 10 million tweets, which is not that much, you're still doing n squared. It's a lot of computation there. So the approach that I took here was to essentially compute a hash function at every tweet. So first, you take a tweet, and then you clean it up. So you lowercase it, you stem it, you remove stop words, and you do this for every tweet. What's interesting is after you clean a tweet, you end up on average with 6.5 tokens, which is really small. I mean, like tweet messages are already kind of limited because they have to, be sent through SMS. So you're capped at 140 characters. But it's actually a lot smaller than that once you clean out kind of the noisy words like it and the and stuff. Ends up with like 6.5 tokens. And if you assume like 5 characters a word, you're talking maybe like 30 bytes about per tweet, which is pretty small. So the nice thing is you could analyze Twitter messages and be able to fit it all in the main memory of like a $200, $300 laptop. But basically, you go through every tweet, and instead of doing this kind of n squared, check everything, clustering kind of technique, you compute a hash function, which basically, after cleaning everything up, you hash every token. And then you take the minimum x samples. And the reason why I take the minimum is to be consistent. And so the more samples you take, the higher similarity you're testing for. So essentially, if you take 2 samples and you turn that into a key, that's usually finding similarity at the topic level. So maybe it's about music or about sports. Once you start to go up to like about 6 tokens, because tweets on average are about 6 tokens, that's almost the same thing as exact string matching. And so this kind of gives you a way to kind of see how much gets covered. So the more unique keys that are generated, that means the more kind of uniqueness there is in the data set. So if you look at 2 tokens, it says about 55% are unique, which means about 45% seem to be colliding. 45% of the messages seem to be colliding on the topics that are found in 55% of the data. And if you start to go up around 6 to 8, you'll notice that there's convergence around 83%, which means that there's probably around 17, 16% of the data that's probably pretty clearly duplicates. So interesting way to kind of look at it, and this is going to be useful later. Another thing that I was interested in looking at was how much search overlap is there. In particular, how much more information do we get from Twitter than from like our query logs at Yahoo or Google or Microsoft? Do we really need to go after Twitter? Do we need to sign a $15 million deal, or do we get all that information for free through query logs? This doesn't exactly answer that question, but it answers maybe a slice of it. What I did was I took the Google trending queries over the span of the Twitter data, and I wanted to compare all the tweets that I have to those queries, and then just see how much overlap there is. And the way I did it was I cleaned all the tweets like I did before, and in fact, when you clean the tweets, you end up with about 6.5 tokens on average. The problem is with web search queries, the average is around 2.5 tokens. So you're comparing something that's much larger to something that's a little bit smaller. And so you need to kind of normalize the length a little bit if you want the similarity to mean something. So I end up taking each query and then query expanding it, which essentially means taking the query, rerunning the query in a search engine, and then finding some most frequent tokens on that search results page, and then adding it to the original query. So now everything's kind of around the same length, and then I could compute a basic similarity metric against everybody. So if I have a tweet, I compare it against every query expanded query in the trending log, and if it matches any of them, it counts as a match. And I just do that for every tweet, and it ends up 2% of tweets end up overlapping with some trending query. And I was expecting a little bit larger, but it may not be that surprising because there's a lot of conversations inside Twitter that have nothing to do with kind of breaking news kind of queries. But nevertheless, it's kind of interesting to kind of get that quantified. Something I didn't cover in these stats is I didn't analyze anything around traffic, growth, even the graph. I didn't try to look at anything around followers or following counts, although those are very interesting, mainly because I was more focused on the content. And also, this stuff has been studied a lot. You can find a lot of these studies online. And here are some stats that I found online, but you could do a couple queries and find these stats very easily. So the insights that we captured from all this that's going to shape the applications that we end up developing with Twitter. One is there's redundancy, and we need to be able to handle that. There's a small number of contributors generating content. I mean, I think you don't have to do any studies to really know that, but it's always good to confirm it. And the implication of that means that let's say you're trying to decide whether you should go buy Firehose data or not. If most of the content is being generated by a small group of users, you may be able to approximate that by just crawling those users as opposed to maybe trying to crawl everybody. Because if they're just duplicating the content anyways, at least you could get some decent sample size just by crawling a small number of users. The other thing is there's lots of URLs being shared in Twitter. And this is actually the main motivation why we ended up applying Twitter stuff to the Delicious website, which is a social bookmarking page or a bookmarking site that's all about how you share URLs. So it just made like natural sense to connect the dots. And tweets are incredibly short. Even though they're already short to begin with, they're really short after you clean it on average. So that means you could put all this stuff in main memory and do a lot of things that would have before been pretty expensive to do. You could do it really quickly and really cheaply. The other question that we kind of had to decide is, do we want to build something where we just use the tweets by themselves? And it's kind of hard to justify that when you kind of look at some of the tweets that are out there. I mean, this is actually not very hard to find. I literally was trying to find a normal tweet, and I ended up finding this tweet. It's hard to make something interesting and relevant that won't offend my mom when you rely on user-generated content that you don't really understand, and it's really short. There isn't much like page rank going on, although you might be able to do it at the user level. It's very noisy. So instead, we need some baseline for what authority is. And so the model that we ended up opting for was let's take existing authoritative content, which is news articles, CNN, those guys, and use Twitter as a way to supplement those articles. And what that does is because we're using our the selection for information is coming from traditional news outlets, it's already filtering a lot of the noise, because when you try to match a tweet to that article, it has to be corresponding to that topic. So that ends up removing a lot of noise, and also makes the Twitter feature kind of optional. So you don't interfere with the existing interface. So it's a nice lightweight way to kind of incorporate social metadata without having to completely rework interfaces that people are already used to around authoritative content. And I'll show an example of this. So this ended up resulting in something called Tweet News. I mean, this is not very interesting. At least that's what I thought. I mean, there was 100 lines of code. It used something called Yahoo Boss, which opens up search stuff. And in particular, we use the news service there. And so the way it works is here we have a query called Avatar. And you go and you run that on Boss, and you get the latest results from news search. And then you essentially run that same query on Twitter search, and you get all the tweets for Avatar. And then you stitch them together in the same way where we were doing the overlap for determining overlap between queries and tweets. So you determine which tweets correspond to which articles, and then you essentially overlay it underneath the authoritative content. And so essentially underneath the result, you have a count of how many tweets are related to that article. It's kind of rolled up, so if you want to see it, you have to press the expando, it ajaxes out, you don't have to hit a page refresh, and you can see the tweets. And so this is like a lightweight way of doing it, because people are already used to a search results page like this. But at the same time, it incorporates tweets as like comments around that article. And it's also kind of optional because you don't have to pollute your whole page with tweets that may be noisy. You do it when you want to see additional information. In addition, seeing the count of how many related tweets there are underneath the result actually provides useful signal for the user. If you see that there's a lot of tweets buzzing around a certain topic, you might be interested in that result more. So we end up actually using the number of related tweets in the ranking formula. So we would use that in conjunction with other features to try to figure out relevance in the context of freshness, which is really hard. And one of the reasons for that is if you look at algorithms like PageRank, right? It's about having an article and then how many people are linking to you and how many are linking to that and so forth. But if your content's really fresh, there's not enough time for that stuff to get linked. And that's why you see like Google News sites where they do a lot of clustering. This is kind of the basic idea, but instead of using news, which is slow, we use tweets, which we hope is faster. And so I just put it on my blog, and I mean it was like a quick 100 lines of code, and it kind of picked up. I think my timing was really good because that sounds really bad because the same day the U.S. Airways aircraft had crashed into the Hudson, and I think news sites were looking into Twitter, and then they may have stumbled upon this, and they thought this was a really good way to kind of see authoritative content and tweets all in one. And it got tech crunched, and the funny thing is I didn't build this on like my own servers or Yahoo servers. I built this on Google App Engine just to kind of show that we could be open too. Boss was about being open, run it on something that's free, and then people can take that code and run it on their own without having to pay anything. Because I think App Engine is one of the few cloud computing platforms that actually has a free quota. And I think the first comment on TechCrunch was it's down, and the page you get back was like App Engine is down. And then if you look at the comments on TechCrunch, it's like App Engine is down, App Engine is down, App Engine is down. And so we got in contact with the Google guys. I guess it's not very good PR when your scalable cloud computing platform appears to be down. Although it wasn't their fault. It's just I busted the 5 million page quota. So they increased my quotas like 10x, which was great because they haven't reset it yet. I probably shouldn't have said that here. No, it was really motivating to kind of see that kind of feedback for something that I thought was really, really simple. And I think it kind of goes to show that even in a game like search, which is just insanely competitive, you have 3 big companies out there who are just dropping millions of dollars every day trying to improve stuff. And you could write a 100-line kind of script and demonstrate some inefficiencies in search, which may be solved better if you look at things like freshness and Twitter and social information. And so, I think these types of examples are very motivating and worth exploring in an academic sense as well. So how does it work in the back end? Just very, very high level. Basically, we go and crawl a lot of tweets, and we do an inverted index on those tweets, and we keep that in main memory. And then you give me a list of content. It doesn't have to be search results. It could be any list of content, any articles. And then for each article, I take the title, and I just run that as a query on my Twitter search index. And I look at the top matching results, and I just make sure that the similarity between the title and the tweet is high enough, and then I count that as a match. It's really simple. And the threshold is pretty relaxed here. It's really easy to make tweets match exactly to an article. But the problem is it's identical. So when someone clicks related tweets, they're just going to see the title like 5 times. So instead, you want to be able to add diversity and add, get better recall and add things that were maybe not a part of that article to begin with. So you end up removing tweets that are too closely similar to the title of the actual authoritative content. And the advantage of this is, you find really interesting, bizarre tweets that are somewhat related to the topic. But at the same time, you could get noise too, because you could get tweets that have nothing to do with that article. But I decided just to do that because I thought it was kind of interesting. I remember a few days after after I put tweet news out there, I think the Chris Brown incident happened, and I remember just like just checking what results came up and what tweets came up on tweet news, and I remember looking at the related tweets and reading it, and I think that was the first time I ever laughed out loud on the internet, and that stuff wouldn't have shown up if I used too high of a threshold. That stuff was really kind of a little off topic, but I thought it was worth doing because it's just an experiment. So we were very motivated by this, so we decided to apply this model to Delicious.com. Again, Delicious.com is a social bookmarking site. It's one of the most famous ones. It's like a top 50 website by Time Magazine last year. And the homepage, unfortunately, hasn't been changed in a very long time. I think it's still the same. Before we had modified it, I think it was still like Joshua Schachter's code that he had written in his apartment. So it's been a while since we've updated that page. And before, what Deliciouscom was, it was basically articles that were ranked based on the bookmark count. So you would end up seeing articles, and they'd have like 100+ bookmarks. And I mean, that's great, but it's not really fresh, because it takes a while to get 100 bookmarks, just like it takes a while to get a lot of links in PageRank. And so the traffic to the homepage was good, but we felt that we could probably do better, and it hasn't been changed enough. So we're just going to try an experiment on the page. So instead, we got instead of using kind of news results, search results, we got the latest delicious bookmarks. So we have this feed that's giving us all the bookmarks that are being bookmarked right now, and we literally take that and we compute kind of how many related tweets are there to those articles. And factoring that and a couple other features, we can determine an order of results up here. So it's not 100 lines anymore, but it's still fundamentally the same model. And we also use the overlay model where we show related tweets underneath each result. So this is actually live right now. And when we launched this, I mean, traffic increased several orders of magnitude. And it wasn't just launch fever. Several weeks after that, the traffic still sustained. And we were looking into it, and I think it just comes down to kind of basic stuff. I mean, I think people there wasn't really a philosophy behind the Delicious homepage. The Delicious homepage before, I think, was just like a byproduct of the system itself. You have these people, they're bookmarking things, it goes to their personal history, and it's kind of like left at that. But by saying that, hey, the homepage can deliver value, you could come here anytime you want to get an update on what's hot right now. It gives people more reason to come back more often because the page is changing more often. The other thing is, by using Twitter, we actually ended up neutralizing Twitter's Delicious's kind of spectrum of people that use the site. So if you look at the most popular tags on Delicious, the most popular tag is like Photoshop or design. And so every time you went on the homepage, I used to make bets on this. Like you'd always see an article like 101 Photoshop hacks, and it was always on the page. And I mean that's great for the community, but it's not really general enough. And so by using Twitter and using the bookmark information in Delicious, we end up getting something that's somewhere in between. And that seems to increase the applicability for more users, which I think might be helping in terms of increasing the traffic. So something I didn't address in this talk until now is spam. Spam is an issue, and it hasn't really been dealt with in Twitter either. Like if you do queries on search.twitter.com, you find a decent amount of spam. And one thing they do on their homepage is they show all the trending topics, like Haiti or Follow Friday or something like that. And when you click on that trending topic, it returns you results. But the problem is everyone knows that's a trending topic, and everyone knows people are searching that. So they end up writing tweets, and then they just put the trending topic in there, and they put a spam link. And you can't really tell if it's spam because they're using all these kind of like shorteners. So it's a problem. And in fact, we started seeing this on Delicious homepage too. People would look at the top result, they would see the title, and then they would just write tweets that had the title words, and then push randomly link crap from that, or just say gibberish like Viagra or something like that. So people look at a system and then they try to come up with ways to spam it. And it's unfortunate because the Twitter information you get back from Twitter directly, it doesn't come with a spam filter. You have to still do the spam filtering on your side. Which I think hopefully will change, or maybe more help can be given to Twitter to kind of fix that. But you have to kind of deal with spam early on, especially when you're relying on user-generated content. Spam is almost the norm and not the exception. So a couple strategies for spam. If you want to spam Delicious, here's how you do it. Or many sites that even try to use this model. You take the title or whatever words are being used to link tweets, and you put that in your tweet. The other thing you could do is you could take a URL and you could bookmark it in Delicious, and then you send a bunch of tweets about that URL. The other thing is you could try to do most of your attacks on the weekend. And the reason for that is because there's not that many articles on weekends. The number of news articles that get generated is actually really tiny. And the amount of traffic and the amount of tweets that are being generated around those topics is really tiny. So even if you update your page often, which we do on Delicious, the chances are, because the content pool is so small, we might end up recycling what was there before. So from an anti-spam perspective, I mean, we use a lot of things to kind of fix this, but filtering near duplicates actually helps a lot. The techniques I was describing before, even if you use like min hashing techniques or something like that, it helps because spammers, they try to send things and they try to send it often, and they might try to change it up a little bit and use a different user account and send that too. And they think that, oh, if we just produce like 20 million tweets, we'll get our article up all the way at the top. But if you filter out in your duplicates, a lot of that stuff just becomes wasted effort for them. The other thing is you look at usernames and you make sure that the usernames that are being related to an article is unique. So that way you don't show multiple users on the same page. And unfortunately, the Twitter search page, they show a lot of users. They show redundant users on the search page, and I never quite understood that. I think they should collapse that down to something because that could lead to a lot more spam. The other thing is to update very quickly. Because we could do this stuff really fast, we could take a set of articles coming in and we could rank it in like a couple seconds with the Twitter the Twitter overlay model. So why not just keep running that job over and over and over again? So we keep recrawling tweets, we keep rerunning the ranking, we keep checking for new articles that are being popular and delicious. So it's really hard to kind of keep spamming and keep spamming successfully in that model. The other thing is to look at users and look at the user activity inside Delicious, and also look at the user activity on Twitter. Something that should be done, I think more work can be done on, is user reputation inside networks like Delicious, like Twitter and Delicious. There is a paper, came from I think Germany, called Spear, which was a technique for being able to detect spammers and associate authority to users on Delicious. And so maybe a lot of those techniques can be applied here or even to the Twitter network. But user reputation, I think, could be really valuable here. The other thing is blacklist. I mean, that's basic. I mean, you could paste, if you know a user is spamming, you put them in the blacklist. If a tweet has profanity or Viagra or something like that, you put that in a blacklist and filter tweets that have those words. But I don't like blacklist that much because it doesn't scale very well. And the best feature is just using multiple features. Don't rely on one technique for determining relevance. Use a lot of different features that kind of cancel each other's problems. So that's what I have. And happy to answer any questions on this stuff, and or even show you guys some live examples if you guys are interested.
Questions?
Can you show us the reference tempo? Sure. Not very good with Windows. Oh. Is there a way to just go here?
So, somebody who's on Stanford University, somebody in this room, yeah, can you put him on the guest wireless?
Yeah. Yeah, me neither.
I know that you were taking notes, not doing green notes.
Yeah.
I'm just wondering if you have any insight as to why Yahoo changed the Delicious domain name from the really cool del.icio.us to delicious.com, which is
Well, they still preserve the old one, so it'll redirect.
It'll still redirect, yeah, but now like the official one is delicious.com.
Yeah, I think that was mainly because the users that they were trying to attract just couldn't spell it, and they just didn't know where the breaks were. And Joshua was really clever in coming up with that, but sometimes it's a little too clever for some people to kind of remember where the breaks are. And I think there's some SEO issues with that too. But it's they bought Delicious.com. I don't know how much that costs, but
So you should be able to get on the wireless now.
okay.
You can log in
Go to Stanford.
as Vik Singh. So just go to a web page. Username is Vik Singh. Password is HCI. 547.
HCI. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 547. 5 Oh, caps lock. Oops. So the old homepage for Delicious was this. And if you actually look at the popular tags, you have like design, blog, video. I mean, Delicious caters to a more geeky audience than the normal social network, which is actually a reason why I like it. I mean, like if you're trying to find something like a needle in a haystack, like you want to know what the best antivirus software is, you do that search on like Google, Yahoo, or Microsoft. Even today, you don't know which one's the right one. Like a lot of them might have spyware. But the nice thing with Delicious is you get all the bookmark counts associated to it. So pretty much if there's one that has a lot of bookmark counts, it's probably the best antivirus software on the planet. So what happens here is you look at the bookmark counts and everything's basically 100 plus. And the top, I mean, there's language issues here. It's more developer oriented. And what we want to do is try to make it more mainstream and more newsworthy. And so if you do the fresh, which is default now, you end up with articles like this. And you'll notice that even for certain results, like this one only has 2 results, or 2 bookmarks. So this is probably pretty fresh. But it's still able to determine that there's some popularity associated to it because people on Twitter are talking about China. 3, 4 bookmarks. And it's really tricky because I remember before a lot of the models that we're using for ranking, we would dismiss, just completely filter out results that had like 4 bookmarks or 3 bookmarks. But there's a lot of value to it because eventually every bookmark starts out with 1 or 2. It doesn't mean you dismiss it until it gets big. It's just too slow. And let's see here. If you go like under a result, you can kind of look at the related tweets. And it's talking about how astronauts are sending their first live tweets from space. And you can kind of just keep reading more. And you'll notice too that all the duplicates are kind of, for the most part, removed because we're trying to get as much diversity as possible. So even when we get tweets underneath a result, we try to make sure that there's distance between the tweets themselves. But this stuff can still be improved, but it seems to be working. Yeah.
I really like what you did with stitching Twitter to like authoritative content to sort of whatever, just like give it some more structure. But like the really interesting tweets are like the ones you brought up, like the guy on the ferry who happened to take a picture of the plane on the Hudson. Is there any model where you can surface stuff like that, where there isn't like a news story that sort of ties the conversation together?
Yeah, so one of the things we were looking into, and I forget what the stats are, but people think that Twitter breaks articles faster than traditional news. That's not exactly true based on some stuff that we looked at. Usually there's a news article out there that talks about it first, because most people who are tweeting about it actually learned about it from the news. They just react faster. And news don't react to each other faster. So traditional news don't lump up quickly enough. But most of the time, the first breaking story is not coming from Twitter. But when it does happen, I think Hudson might have been like that. Although I think there were phone calls coming in from like news outlets too. I think it was really close. It's tricky because people have been looking at that problem and they were like saying, oh, what if we just looked at the user graph? Let's just do like reputation within users. The problem is those guys who were tweeting out the first pictures of the Hudson had no reputation. It's a really tricky problem. I think you have to, either you could predict, these guys are gonna figure it out in some clever way, or you have to wait, but you hope that the waiting period's really short. So in this case, we're saying that traditional news does an okay job generating content quickly. The problem is it doesn't rank well enough. It doesn't have enough of that traditional web backing to get high enough. And so we rely on Twitter. So it's a little bit delayed, but I think there's room for improvement.
A fundamental problem there because if you're looking for the first post on this topic, you have no way of verifying the information. So if you start focusing on those kind of posts, spammers will instantly start making up news stories. And since you're looking for the first one, you have no way of knowing if it's true or not.
Yeah, exactly. And in fact, on the slide where I was talking about Twitter by itself being kind of standalone garbage, the main issue with that stuff is it's unverified. I mean, we don't know if it's false. It could be offensive. So using authoritative content like traditional news as kind of a filter and then finding tweets around that topic seems to get us around those issues, but there could be a delay. But it's very unlikely that traditional news is doing a decent job finding it. It just doesn't rank it fast enough.
Maybe this is kind of taking another cut of that around the question of is how much of just an epiphenomenon is Twitter, an epiphenomenon with respect to other activity, particularly say traditional SMS or cell phone interaction, email interaction, as well as general internet or this stuff. And maybe one distinguishing thing is do you see a notion of a way of attaching, looking for a notion of narrative in here, other than just topic. And for instance, the question is, if you filter out celebrity-based topics and scandal du jour topics, is there anything left? For an example, and looking for a residue, a longitudinal residue in each one of these things, and then maybe saying, with respect to that narrative, does one lead or lag or correlate, lead or lag with another?
Yeah, I mean, I think that would be great to study. I think I kind of scratched the surface a little bit. I think when I checked how tweets relate to query logs and spiking query logs, checking it against emails would be really, really valuable too. I know Yahoo News has a filter where you could rank articles based on how how frequent they are. But I don't know if it has a rising notion to it. I think it's mostly based on aggregate count, like how many emails are there around a link. And actually, one of the things that's kind of interesting is there are models where they take Twitter results and they map it to other content, but they just look at the outbound link. So if that tweet has a URL and that authoritative content has a URL, if it matches the same outbound URL, they do it. In this case, we're actually being a little more liberal, and we're saying you don't even have to have a URL. If you just have matching tokens at the title level, then we'll just say you're good enough. And that gives us a lot more recall. But kind of going back to your point, I think that's the right way to do it. If you could break it down into topics and then see, first off, how much information gain are you getting from Twitter? And then how does it compare to other things like email, query logs, and things like that? Would be a very interesting study. I just don't know.
Or another tech might be, what role are the participants playing with respect to this communication media? Are they drivers or are they followers? Do they represent some Jungian archetype? That they see themselves as a hero? Something.
There are some stats, like if you go to Mashable and things, you type in Mashable Twitter stats, you're going to find a ton of stuff about demographics about users. But one thing that you could maybe infer from some of the stats that I demonstrated is that there's a lot of communication going between users. And I think that's referenced based on the ampersands. People are replying to people directly, and that's like 39% of tweets have an ampersand in it. The fact that people even know how to do that is pretty remarkable, right? Because Twitter is just like this basic dumb protocol. It's just a text message. And then people started building standards by themselves and saying, if you want to reply to someone, use an ampersand. If you want to put tags in your tweet, use hashtags. And you come to Twitter for the first time, it's like you think you're on the Linux command shell. It's insane. And yet 39% of tweets have ampersands on them. And so there's a lot of communication between people. Obviously, you're going to have a lot of followers in Twitter, just like you would have in any social network. So just like the graph style showing, you have a very small number of users who are generating most of the content. You have most users sending one message or less per day. I mean, that's why it's kind of like that. But so the amount of content that's being generated is coming from a small number of users. But I think there's so much passive elements to Twitter that are hard to measure. Like if I see something, I may not react to it, but I saw it. And that should be measured in some way. The amount of impact that someone has. Maybe the best way to do that is to look at their follower count, because then you know how many people are following that person. Looking at those types of studies would be looking at those types of stats would be very interesting, I think. I mean, all this stuff is open ground. I mean, like companies are literally trying to do a lot of things to try to make Twitter work in search and all these different places because they think there's a lot of valuable metadata there. And it's also like this kind of free, real-time social network. Because Facebook has a lot of really great data, but it's been fairly closed. And I think people are looking at Twitter to kind of get more information. So people are trying to find ways to use this stuff to kind of maybe cancel out some of the benefits you get from Facebook. Maybe you get some of that for free and then stitch it to other places, like based on your task, as opposed to coming to one network and getting everything. How it plays out, we'll see, which is kind of the fun part.
Okay, any questions? All right, thank you.
All right, thanks.
For more, please visit us at stanford.edu.